Well, good morning. Not sure we've started. Well, good morning. Hopefully we've started. My name is Alan Barton, and it's my pleasure to chair this webinar on re-engineering for sustainability. Equally, it's my pleasure to introduce the speakers Tom Fester and Harvey Leach. Harvey worked with Rover Group and BMW for 25 years in a variety of roles from research, product development, production control, and manufacturing strategy. He left Mini in 2004, and since then he's been working as a consultant and trainer in the production and product system process improvement, working with the IMechE learning and development team since 2010. Tom has worked for over 20 years with BMW Mini, including positions in the new vehicle project manager. He's co-founder of Recharge Limited, converting classic minis to EV Mini Recharge, and author of the IMechE Re-Engineering for Sustainability training course. Good luck, Tom and Harvey. Over to you.
So, hello everyone. I'm Tom Fester, as Alan kindly introduced. So I've got the pleasure of talking to you about re-engineering for sustainability. So let me share my screen. We'll get cracking. There we go. Just give me a moment. Right. So hopefully everyone can see my screen. I'm sure you can. So what we're going to talk about today, just get the thing to work. Is sustainability in a circular economy. And then I'm going to hand over to Harvey, who's going to quickly talk about applying sustainable thinking to new product design, development and production systems. And we're going to give you the opportunity to direct you to the IMechE areas where you can find out more and learn more. And of course, we're going to have a small Q&A session at the end. So get busy scribbling your questions. Alan will facilitate those questions to us. So, sustainability in a circular economy, what does that actually mean? The two words here, sustainability and economy. What I will say is that engineers have got a lot of leverage for both. Their engineering affects the sustainability and certainly the economy. Sustainability has been defined in many ways. The one I use as a definition is the UN sort of Sustainable Development Goals from the summit back in 2015. So sustainability is actually multifaceted. At the centre, sure enough, you would expect to see the environmental pillar. But of course, there's the economic side of things. And the social side of things too. And together, there's a phrase that's coined, which is the triple bottom line. So we can be at an extreme, ultra sustainable from an environmental perspective, but that won't necessarily put food on the table. And that would certainly have a big social impact. So we do need a sustainable economic, environmental and social pillar to work together. And as I said, engineers have got a lot of impact. So nowadays, what's happening is that that triple bottom line is seen as being important by investors. The financial institutions are now demanding that companies work in a sustainable fashion that encompasses really the triple bottom line. So you should be familiar already with the ESG, environmental social governance, which investors use to judge companies. Now at the bottom here, you can see some companies that do just that. They rate other companies to see how well they're doing from a sustainability perspective. So they use the word sustainability, which really encompasses environmental, social, and the economic practices of the company. Very often, the statements made by companies which are being assessed come from the marketing departments, but in reality, the basis from what they're talking about and the claims that they're making are often embedded from what engineers are actually and project leaders are actually doing in delivering sustainability goals. And that goes beyond the company itself. It actually also goes into the supply chain. So it's no good just moving the bad things you're doing from your company and pushing it upstream or downstream. So you make the claim, hey, I'm not doing this. We need to see it holistically in the supply chain. And the investors who are judging ESG now are increasingly looking at those supply chains too. And that's sort of a nice segue into greenhouse gases. There's a protocol which talks about scope 1, 2, and 3. Scope 1 is pretty much what the company's doing directly. Very often, in terms of the big picture, that only represents 5-10% of the total greenhouse gases that are being produced by the manufacturing process and the actual user part of that thing, that product that a company is designed. So, something to note here is the type of greenhouse gases. We often talk about carbon, reducing carbon into the atmosphere. Actually, what we're really talking about is CO2, it's carbon dioxide. But actually, not all greenhouse gases contain carbon, let alone carbon dioxide. So we've got things like methane and nitrous oxides, hydrofluorocarbons. So what we do now is start to talk about CO2e, the equivalent. So some of these, well, all of these actually punch way over the weight of equivalent of CO2. So methane, for example, if you emit 1 gram of methane, it's the equivalent of emitting 25 grams of CO2. And it gets worse. Some of these compounds, like nitrotrifluoride, the one on the extreme right, that's closer to 20,000. So at this stage, what I would do is encourage all engineers to understand their processes and understand whether any of these gases are being emitted. Because they're obviously all contributing to global warming. So there's 3 principles that we should bear in mind as engineers. We should be trying to design out waste, number 1, and pollution. The products that we engineer and those materials that have been used in manufacturing those products should be used as long as possible. So the life of a product should be elongated as much as possible. And then eventually when the product comes to its end of life, then hopefully those materials utilized can be regenerated into the natural system. So as engineers, there's a lot of research has been done, and when you look at the R&D costs of engineering a product in terms of its total life cycle, then that engineering cost is about 5% on average, according to McKinsey. What engineers don't realize is that the 80% of a product's lifetime emissions are also been determined at the design stage. And this is why I'd like to point out that engineers have a hell of a lot of leverage. 80% of the lifetime emissions are determined by the engineers involved, project managers, and so on. So what should we be doing in a sort of a circular economy thinking? Well, first of all, is to reduce the amount of new material that's required. So that ought to be reduced throughout the entire supply chain. And then I would ask all engineers to rethink, is there a better way? Can we use materials that have already been used once? So I come from the car industry, and I know that 50% of a steel body has probably been a steel body before. And now batteries that are increasingly being utilized, they can be recycled up to 90%. I mean, the car industry has been an industry which has created a lot of CO2 gases and has contributed enormously to global warming. But out of adversity, that industry is now finding opportunity to redefine and to reinvent itself. And I would ask that anyone who's involved in the design process of introducing new products should be trying to think in this way. So there's opportunities out there. We don't always need a physical product. Sometimes we can offer a service rather than a product. I've mentioned the product lifecycle should be extended as far as possible. So how's that designed? I mean, how do we do those updates? Certainly in the car industry, the software is continuously updated through telemetry now in cars. And you will see increasingly that even parts of cars can be updated by replacing with new modules, updated modules. The materials used, I mean, if you can use recycled material, then do so. I know several companies now have got pilot projects where the only materials they're allowed to use are materials that have been in another product. So these are recycled materials. They will not utilize any new freshly mined materials at all. And certainly what I mentioned before, the modular approach to upgrading the product by replacing with a module and then maybe updating that module in its own right. Sharing platforms. Again, module thinking is really important. Once you've designed a module, then the engineering and resources that have gone in to develop that, I mean, if it can be utilized widely and be interchangeable with as many products as possible, then that's always a good thing. Ultimately, every product will come to some sort of end of life. So a car, it could be that's involved in an accident before it's actually no longer viable as a product. But then, I mean, how, for example, I use cars as an example. I mean, how is it broken down? How's it picked into the constituent components that can be more easily recycled? Certainly, the automotive industry thinks about that a lot, and certain practices of co-molding several materials that can't be stripped back are avoided now. And then obviously type 1 is the manufacturer, but type 2 is where your energy comes from. Be clear where you get your energy from. So these are just some examples of new product introduction, rethinking processes. I mean, if you come onto the course, and I would elaborate on many of those opportunities. CO2e is a unit of measure, and it's not one that's really understood in the same way as a kilogram or a meter, other units of measure that engineers work with. And it's something that would encourage all engineers to understand. It is a really important unit of measure to understand how that unit is compounding and growing. So in the future, this unit of measure will be monitored as we monitor money, currencies. Again, we will understand currencies, but CO2 you will see being followed in blockchain type transactions, where we're sort of understanding blockchains in terms of cryptocurrency, but actually following CO2, so we can attribute that to a particular product over its lifetime. It is something that we'll begin to see more and more. That's already quite complicated. The thing that will feed into that will be the Internet of Things. There are a lot of measurements taken in the internet. Some directly, some indirectly, will be measuring CO2 equivalents, materials utilized and emitted. So if you can imagine the Internet of Things feeding the blockchain, then we're going to get some better clarity on how much CO2 this new unit that we all need to live, breathe, and understand and be aware of, how that's developing. So what I want to do now is just end with an example, at least my section, before I hand over to Harvey. So Adidas, away from the car industry, wanted to make an ultra-low shoe with ultra-low carbon footprint, pardon the pun. And what they managed to do is cut the CO2e equivalent, the carbon footprint, by 80%. So they got a carbon footprint of 2.94 kilograms. And they're really proud of this. They advertise this on their shoe and on their social media. They are, and rightly so, they are really proud. They've done everything to reduce and reuse, rethink, and they've got an 80% reduction. But just to put that into context, what is the weight of a shoe? A pair of shoes weighs 0.5 of a kilogram. So having reduced it by 80% to 2.94, I mean, we're still sort of a factor of 6 carbon equivalent CO2 been produced and emitted into the biosphere in order to produce a shoe that weighs half a kilogram. So that begins to put into perspective just how much CO2 has been produced and emitted into the atmosphere in comparison to a pair of shoes that you can pick up, wear, and sort of understand. So again, if you come onto the course, we'll lead you to get that better understanding of how this thing that we can't see is emitted, and how we can all reduce it. So at this point, I'd like to hand over to my colleague Harvey Leach. Over to you, Harvey.
Tom, we can't hear Harvey. Can you give him a call?
Aha, it's all right. I've got it. I've just suddenly realised, Alan, I hadn't put my microphone on. I put the slides on, forgot to put my microphone on, so I'll start again. Can everybody hear me now? Yes, I hope. Yeah, can you hear me now? I apologise for the mistake.
Yeah, we can hear you.
Yeah, cool. So no, what I was saying, only to myself, is that, you know, working in a world where we are hopefully working with new products, in our case, or in the case of a lot of you in the audience today, if you work in sort of process industries, we're talking about facilities that will process stuff. Whichever it is, you know, going back to Tom's quote, that sort of 80% of the environmental impact is actually determined by the design decisions that are made. You know, and experience says, you know, over the years, people have shown that it's not just that, it's impact on ease of manufacture, on ease of cost. So it's not surprising to see this 80% number. It's reinforcing stuff that we've known for many years. And so what I want to talk about in this section is how we turn some of that desire into practical action. What are some of the things we can do? What are some of the considerations we need to bring in to our design and development process? Because as Tom started to illustrate in his section, traditionally, we've thought of a product life cycle as a very linear thing. So that flow down the left of the diagram that you see in front of you, you know, this section of the diagram here, that we start off with materials, we go through a process of designing and developing parts, a manufacturing process, distribution. We think about product life. We think about perhaps collecting, disposing of the materials at the end of life, and everything at some point ends up being burned or ends up in landfill. And that was a very traditional thing. And we've talked about recycling a lot for many, many years, which is to try to get materials back and put them back into the front end of that process, this external loop. But I think one of the things that is becoming more and more significant is whether we can do other things that make our product life cycles more sustainable. You know, can we consider taking things apart and reusing the actual components rather than recycling them, so we actually get things back into the system without wasting, as it were, the extra energy and effort required to get back to raw material and remaking. You know, can we extend the life of products? You know, there's a lot of discussion about right to repair, isn't there? You know, we've seen, certainly over my lifetime, you know, the trend in products has actually been more towards products that have a short life cycle, they're not easy to repair because the driver's been getting costs down. And one of the ways you get costs down is perhaps engineer out that repairability. And we're starting to see those trends reversed so that we can actually extend product life, which requires a bit of rethinking in terms of the way we approach markets, the way we think about our business. You know, perhaps find alternative uses for product. And the only way we'll do that is to think about, in a broader picture sense, about our design and development process. So it's not just the pollution and waste in the production process itself, it's thinking about the broader impact on environment over the life of our product, and even broader on, you know, the whole way we go about designing and manufacturing product. But if we come back to the idea of design, perhaps there's a useful hierarchy in terms of some of the ways the questions we ask ourselves during the design process. You know, because this nice little pyramid here on the left-hand side, we're talking about what has the most and least impact on the planet. Because at one level, you know, our old linear economy that says we use something, dispose of it, is clearly having the highest impact on the planet. If we can avoid something altogether, if we can avoid making a new product altogether by extending the life of an existing product, in a way that has the least impact. But in between, we can be talking about recovering materials, reusing materials, or reducing the amount of material we use. So there's definitely a hierarchy to consider when we think about the design process. Because traditionally, if we go back a long way, we would have just thought about products as designed for function. And the idea of design for manufacture, design for assembly has been around for a very long time. And the design for manufacturability course that I run for IMechE is one of the most popular courses. So that's clearly a topic that's got a lot of traction, because ease of manufacture, with it the consequential reduction in total product cost, is a valuable topic for many organizations. It's something they look at. What becomes less attractive, and I find it really interesting, that far fewer engineers have been coming on courses that look more broadly beyond that manufacture and assembly. If we try and think about it from a sustainability point of view, we immediately start to think about design for sourcing. Where are we getting product from? How many sea miles or air miles? What are the operating regimes of the suppliers we're using? So we can start to think about where we're sourcing from, who we're sourcing from. We start to broaden that into, are we using sustainable material sources, which then impacts on our material choices, feeding back in there, and can we source in ways that meet all of those three dimensions of sustainability that Tom talked about? So not just the environmental impact, but the impact on society and people as well. Because one of the things that Tom and I are acutely aware of is, with the move to electric vehicles being promoted as a very positive thing in terms of how environmentally friendly they are in use, but we have to think about the impact on certain economies where, cobalt, for example, is a really valuable commodity in manufacturing EV batteries, but cobalt mining itself is very damaging, both for the environment in the areas where it's mined, and the impact on the way the employees in those industries are treated, the impact on the local environment, and so on, is quite detrimental, even though it's having some economic benefits. So thinking about where and how we source things and what we source becomes important. But then we also need to consider in our our whole design thinking, what are we doing in terms of the use of a product and its ease of maintenance and repairability? What's its impact there? And then thinking more sustainably about what happens at the end of a product's life, in terms of the ability to reuse the products or components, to recover the raw materials, to recycle where we can, and to dispose safely of those materials and products that we're not able to feed back in a circular way, and to minimize those as far as possible. And the thing to remember, or the thing that was interesting to think about, is that this doesn't need necessarily a revolution in the way that we design and develop products. Certainly in the automotive industry, over the years, a lot of the things that have been done in the era of lean manufacturing and design for manufacture and all of those sort of things have already brought products to a point of view where, in many regards, they are more sustainable. And using the same methods and thinking that got us to that point will help us make the next steps in the sustainability journey, if you like. The idea of continuous improvement, Kaizen, is kind of a word that's entered common parlance. The idea of small steps of improvement. And it doesn't take much of a leap to turn that Kaizen process that's working in many organizations into one that says, how can we start to make small improvements in the sustainability of our products as we make evolution of the current product that we make? And that becomes quite an easy small step thing to do. But one of the things you learn about Kaizen is lots of small steps very quickly add up to one big step. I think Tom showed some numbers in a course we were doing earlier in the week, that if we could just make 1% improvement in what we do per day, 1 to the power of 365 comes up with a number about 37. So we can be 37 times better by the end of the year than we were at the beginning. And that might be a small thing in the way we work every day if we can look for opportunities. And then, on top of that, we need to think about some of the big moves that perhaps aren't possible with current products, that need a new generation of product and so on, or things that require a significant level of investment in our product or our production plant. And there's examples there on the screen, things that we invest in. You'll see lots of factories now, they're starting to put solar panels on the roof, different systems, thinking about different supplier strategies, making different decisions about where we source stuff from, and maybe slightly bigger shifts. And then we get the sort of strategic moves, could be even moving out of certain business sectors, bringing in new technology, new concepts. But the opportunities to do those are much fewer and further between. They're much bigger investments. It might be investment in a whole new factory. And so we'll need a mix of all of those things as we go through. And the ones that will give us the most return in the short term are those small step things, decisions we make. So here's an example of how our former employer, BMW Group, would think about all of those dimensions, when it's thinking about the evolution of both its products and its production system. We'll think about the development process. So we might be, we've been thinking about alternative drive concepts. How do we get away from fossil fuels? How do we make the cars more efficient? Design for recycling has been something that's been done for many, many years. I even remember that being around for things like plastics when I was a young engineer 30-something years ago. But then taking that thinking to look at the whole product life cycle. How do we set the right standards for suppliers? How do we make production cleaner? How do we, a lot of the BMW factories are now running on wind power or solar power rather than more traditional systems. How do we think about the transport infrastructure that we have, that we make that more greener? What are some of the things we're building into the product to make it more environmentally friendly, to have lower impact in use? How do we help drivers to drive more fuel efficiently, even if they're still in a combustion engine car? How do we think about safety so that we keep cars in the system longer? How do we manage traffic so we stop cars queuing up? So that's the whole driving infrastructure. We start looking at alternative engines and so on. And then, what are some of the concepts we might think about at the end of a product's life in terms of how do we make sure we bring all those components back? Renault trucks are already doing a great thing where they will buy back the trucks, refurbish them to a modern standard. They'll do the update, but rather than a truck ending up in the scrap heap, it's actually returned to Renault, redeveloped, re-engineered, remanufactured, rather than making a whole new truck. And we're starting to see some of that innovative thinking coming out. So in terms of practical action that you can take, I mentioned that one of the big things is that the idea of lean thinking in the car industry has been around for over 30 years now. And it gives us a lot of the foundation for how we might approach improving our sustainability. One of the core ideas in lean is about identifying value, improving the flow of product through, and most fundamentally to what we're talking about here, eliminating waste. And when we say waste, a lot of the time we think about waste materials or the output of a process. But it's also about how do we make efficient and effective and sustainable use of every step in our production process. because it will save time, it will save money, and it will reduce environmental impact. All of those go towards helping our businesses be more sustainable when we talk about that triple bottom line impact. So for those who are not familiar with them, I suspect these ideas get more and more widespread as time goes on. But when we talk waste here, we're talking about any activity or any material or any process that isn't adding value to the business, isn't directly converting to revenue, is adding to costs without adding value. And just looking at these 7 items here, 7 areas, we could start to look at our total development and production system. What are we putting into our product and to our factories? That waste transport, requires materials to be moved around more than they have to. That requires us to hold more material in stock. People would go, well, how's holding more inventory having an impact on environment? We might use it anyway, but it means we've got to have bigger warehouses which need heating and lighting and people to look after them and cost money to build in the first place. How do we save people moving around too much, which is efficient? Waiting around, is not a great thing. Sometimes the other waste, overproduction, we produce more product than we might need because we're not exactly sure what customer demand is. So we make stuff just in case, and then it has a short shelf life, so it never gets used, or the product becomes obsolete, so people want the new one, not the old one. And so stuff finds its way into the system without necessarily adding value. Are we doing more work on a product than we need to? Are we making products with defects so that we have to scrap parts, we have to rework parts? All of those are things that help towards sustainability, reducing environmental impact. Small moves rather than those big, high media value things, but they're all little things that go together to have a big impact. So things you can do in your own process. Think about which area you're looking at. So define a scope. Tom talked earlier about how we quantify the CO2 equivalent footprint. And there are ways of doing that without it becoming a hugely academic exercise. We can start to think about the CO2 footprint, and I'm sure if people have got questions on that, Tom can pick them up in the Q&A. Look at the areas where it's easy to make changes. We always say go for the quick wins. Don't pick the ones that are expensive and difficult. Pick the ones that are easy to do, that have the highest impact. What's the reward versus effort? The thing we always refer to as quick wins. And it doesn't mean don't forget about the high impact ones, but what it does mean is focus on the ones you can get some quick results on, because of themselves, they'll start to generate additional revenue because you'll have reduced costs or whatever that you can then use to support and inform those bigger picture moves. Another important thing is set goals, set measures. Once you've identified what you're doing, what's the improvement step we're going to make? How are we going to know whether we're being successful? Implement the improvements. Not everything will work perfectly. So is it giving us the result we want? If not, what have we misunderstood? What else do we need to do? Once we've learned it, once we know how to do it, how do we make sure that stays as business as usual? How do we make that part of our routine process? And never be satisfied. There's always room to improve. So I'm going to end with another nice little example of where one particular company, in this case Heinz, looked at one very particular sustainability issue on their product. Because I think we've all grown to love the squeezy bottle of our ketchup. Remembering back to the days where it's in the glass bottle, you shake it, you end up with half a bottle of ketchup on your plate as opposed to the dessert spoonful that you actually wanted. And we love the squeezy bottle, that nice little valve on the end that means we can squeeze out exactly the amount of ketchup that we want. But what Heinz realized was that that plastic cap uses two very different materials. There's whatever the white plastic is that the majority of the cap is, and then there's this flexible silicon valve that is co-molded into the cap. And that co-molding process, Tom mentioned it, one of the classic design for manufacture principles is to reduce the number of parts, and co-molding of plastics was a very popular thing, but it makes them at the least very difficult to recycle. That there's no practical way of extracting that silicon valve from the plastic cap and recycling those two plastics separately. And so Heinz set a design team around that said, how do we keep all the benefits of the squeezable bottle and eliminate this recycling challenge? So because everybody, if you're being purist environmentally, you could argue going back to the glass bottle is probably the most recyclable thing. Even better, recovering the glass bottles, washing them, using them again. But if we look at the whole, if we look at the bigger picture, we're losing it, and we'll probably end up throwing more tomato ketchup in the bin and so on. So they thought this is a valuable thing to do. And it took them 45 design iterations to actually come up with a better solution. So it looked like a very simple thing. Actually, it's quite difficult. But back to a point Tom made earlier, engineers have a lot of leverage here. We've got the knowledge, the ingenuity, the creativity. And so engineers were really very much at the core of this change. So they came up with a solution for the plastic cap that is actually a single material, two parts that push together rather than having to be welded or co-molded. And that becomes a really recyclable part now. So that, for the plastic bottle with the squeezy top, it's the lowest carbon footprint solution that they could come up with. But in the spirit of there's always more room for improvement, are they satisfied? Tick, we've solved that problem, on to the next one. No, they're starting to think about how can we keep that benefit of the nice, easy, squeezy, deliver as much as you want, without the use of plastics at all. Can we come up, they're looking about ideas like, can we make the bottle of some alternative material? Can we make it out of paper that is, less damaging on the environment to produce and is easily recyclable? Do we start looking at reusable containers that don't have all the disadvantages that the old glass bottle used to have? So just one simple example of how a rethink on a product, a particular aspect of a product, a particular feature of the product, and how can we deliver that in a more sustainable way, takes some effort but delivers a huge benefit. Now that's just touching the surface of how we put this into practice. There's lots of stuff around how do we organize our design and development process and so on. So if these are areas you want to dig in a bit more, as well as sharing information, webinars like these, organizing events, the L&D side of IMechE really wants to give engineers the tools to put some of this into practice. And one of the things Tom and I have been working on over the last few months is these two modules that Tom mentioned at the beginning. One that takes the circular economy ideas that Tom talked about, how do we put those into practice? And then the second one, which builds on some of the things I've been talking about around sustainable life cycle design. And those two modules are available. They're a day each. They're running 2 or 3 times over the next few months. Dates are there. You can go onto the IMechE's website, look at the training calendar to see the dates. If you need any information, contact the training team at the IMechE on the email address that is on the screen. And at that point, thank you for listening. I'm going to hand back to Alan now, who's been looking at some of the questions people have raised in the background, and we'll pick some of those up, and Tom and I will do our best to answer those for you.
Good. Thank you, Tom and Harvey. That was very interesting. We got a question from me first. I go back a long way, and I remember cars being pretty unreliable, and Rust was a prime example. How is that process moved? Because we now have cars that are far more reliable, and how well have we moved towards actually achieving what you've been describing of getting the car to be sustainable? And what drove it all?
If hopefully you guys can hear me, it's Tom here.
Yeah, I can.
Good. Economics. Economics. I mean, it's a very competitive marketplace, cars. So people wanted the highest possible quality and the longevity of a product, and these happen to be sustainable factors as well. So bodies now, they're properly galvanized and they've looked after. I mean, you're measuring the life of a classic steel body now, 20, 30 years is absolutely possible, where 10 years was a stretch back in the 70s. And that's probably got even further to go, but that's galvanizing and painter processes and clever design, so you don't have permanent wet areas in boxes. So engineers have solved a lot of rust problems, and I'm optimistic that engineers will also solve a number of the sustainability environmental issues as well.
Okay, thank you, Tom. We've got one question. The statement that you made that 80% of a product's life is in the emissions from it. What's the source of that?
I can
And
answer
how's
that. It was in I put that in my presentation.
Yeah,
This actually comes from a number of studies, but the one I quoted came from McKinsey.
okay,
It's probably a couple of years old, if that. But a number of studies have looked at this, and they keep on coming up with roughly those ratios. I mean, McKinsey aren't
okay.
alone.
And they're obviously available off the website somewhere.
Yeah, I mean, if you look
well,
up
so.
McKinsey sustainability engineering, and you'll quickly come across that quote and the
Okay.
paper.
Okay. Another question. Apart from qualified CO2e, are there other matrix that should be used to measure the degree of achieving sustainability?
I mean, the obvious metric is currency, money. I tried to explain sustainability it's got a triple bottom line. You can have a product with the lowest CO2e in the world, but if it isn't fit for a purpose and consumers aren't going to buy it, that company is going to go bust. Or if it becomes so expensive, there is a bit of a premium at the moment for sustainable products that are seen to have lower CO2e. But if that's off the scale, I mean, the economics just don't work. So the engineers, and I keep on coming to this time and time again, have to look at the economics of the situation. And that's probably as vital, if not more vital. And investors, they're looking at the economics. Not all investors are there because they're environmental activists. Of course not. They're investors because they want to get a return on their investment. But they're forward thinking, and they can see actually this is the growth market.
Yeah, I mean, I think the other thing I'd add to that, Tom, is that there are sort of sub-metrics you can use. I mean, the nice thing about CO2e is it is a leveler and we can apply equivalence. But if we're looking at a more practical local level, you could start looking at metrics like, what percent of the raw material that's coming into your product is reused rather than virgin raw material that's come out the ground. What percentage of the material in our product is recoverable at the end? So you can start to think about all of those dimensions through the life cycle and put some metrics to those. So that's certainly another way you can start to think about it when assessing the design for sustainability. One of the things Tom didn't mention, but BMW has set goals and principles. The primary challenge for a lot of BMW engineering teams is to use a recycled or recovered material as the primary source and only use brand new when there are no other alternatives in certain areas. So, you can start to measure the adherence, the percentage adherence to that sort of guideline. So those are the other things I might be thinking of.
Can you comment on this sort of, yes, we come up with a quantified level achieved of a matrix, but can it be used to claim this product is sustainable? Question mark. And this whole sort of greenwashing claims by some sectors.
So BMW, if I take as a case, actually won the most awards for sustainable product engineering. Right? They very rarely talk about it. The reason being is that you could probably find a hole in it. What they've done is improve from where they were.
Yeah.
And this is what companies need to do is get a baseline, understand where they are, and start to improve and let other people make the accolades. So sometimes companies get overexcited. They are making improvements. They make a big claim, and then somebody will scrutinize that claim and show actually, it may not be as big as the company is making out to be, because very often they're marketeers making the claim without detailed quantification. And B, there's still a long way to go. So they'll point the gap at the gap. The better way is for other people to give the accolades.
Yeah. Another question here. Economics have driven many decisions over time. Can the presenters comment on whether the true cost of disposal of CO2 enforced by governments, for example, would drive change faster than the triple bottom line?
I can come in again. What's the value of CO2 in terms of a tax? At the moment, if you look at CO2 tax, I mean, it's really varied around the world. The Chinese maybe put a value of it $10 per ton, whereas other states in America will put $100 per ton. The true cost is probably closer to in my opinion, $100 per ton. What we need here is legislation on a global level, to be honest, in order to really reflect the harm that's been done by certain processes in transport to aviation. I mean, many of these are absolutely tax-free. I mean, there's no duty levy on aviation fuel, for example. So the real costs of many services that we've become accustomed to receiving, or products that we use, haven't incorporated the true cost of the CO2 that's been emitted. Now, again, in the car industry, at least in the EU, and the way we tax cars now, I mean, if you've got more polluting cars, even in the UK, you're going to pay a higher tax band. So it's beginning to come in. Again, personal opinion, I think this will increase on a global level. And those companies that don't begin to understand that actually CO2e will convert into some sort of tax penalty will ultimately go bust.
Okay.
Yeah. I think the other thing I'd add to that, Tom, and I think we see it, is that while legislation is really important to drive behavior, the companies that are really going to do the best out of this are the ones that on their own count are thinking longer term. The ones that are leading the market. One of the things that we know is that within the auto industry, BMW are leading the way on this, not because of legislation, but because I think one of the characteristics we see, particularly of, say, German and Japanese companies, they tend to think much longer term than others. So the decisions they make, both financially and otherwise, are based on longer term thinking. So they can see the way things are going and almost trying to act ahead of legislation. So the core, in many ways, is winning hearts and minds and getting organisations to recognise the long-term benefit of sustainable thinking and how that helps their businesses to be sustainable as a profit-making business in the long haul too.
Okay, got one question here. How do you think engineers can influence the societal change required to solve some of these problems, i.e. Moving away from car ownership and promoting active public transport?
So I've already mentioned showing the economics of the thing that engineer believes to be good. So there's a business case. Engineers and should understand the business case. I mean, the very simple definition of an engineer used to be somebody who can design something for £10, where most people can do it for 50. But actually, it's becoming more multifaceted than that. So shared car ownership, there is a market for that. Who's going to step in first? Who's got the right product? Can you put a module on an existing car and suddenly allow it to be utilised by many? Can it be delivered autonomously? I mean, these are all questions that have been asked, and some have already been answered. So I was privileged. I managed several projects for BMW and for Mini. I can tell you, we developed modules which are being used, where multi drivers can use that module. So Drive Now scheme in many cities is being run. You're given a code when you want to book the car. You go to the car, you tap in the code with your phone. You open the car with your iPhone, smartphone. You will then you jump into the car. The car, if you've used it before, will even remember the heater settings, the radio stations that you like. The display will welcome you. Hi, Alan, welcome back. And if it's got electric seats, it'll probably even move the electric seats to your driving position.
Excellent.
So that is all happening. And why is it happening? Is because some bright engineers realized this can be done. And they put a business case together. It is being done.
Excellent.
So don't wait to be asked. Think innovatively and work with your marketeers. Make the business case. Yeah. And in the courses that we run, we talk about this. I mean, how do engineers make the business case, and how do you leverage the sustainability factor?
Yeah. Because in the end, I think it's about engineers learning to express technical arguments in terms that non-engineers can understand and grasp the value of.
Yeah.
You know, when people ask what you say, how do we influence in our organization? It's use the language of the people you're trying to influence, not the language of engineers.
No, that's I totally agree with that, guys. Well, we're run out of time, unfortunately, and we've still got a lot of questions to answer. So apologies to those that ask questions that haven't been asked. Harvey, you're going to put up.
I will put up that final slide for you, Alan. Absolutely will.
Which is going to show if you wish to get CPD, and also there will be a copy of the presentation put on the website, and you should get a link to it. But equally, you can go in the IMechE YouTube and see the presentation as well. Tom, Harvey, and everybody, thank you very much.
You're very welcome. Have a great day, everyone.
It's a pleasure.